So this is the Glenn Research Center budget. This is the 2011 budget, and you'll see it's $665 million. It's if you take out the 38% that relates to what we call CMO and AMO, which are really our G&A and overhead lines that fund maintenance of our facilities. They fund our civil service labor, things like that. Then you go in and you see we receive about $151 million in aeronautics research work, and then we have a science and space operations budget that's roughly 17% of the budget we receive annually. Exploration relates to the next generation of launch vehicles and space capsules, represents another 15%. And then we have a construction account that basically accounts for the balance. So our civil service workforce, about 66% of our people charge to technical programs, so they don't charge to overhead accounts. And we have today at 69%, it tends to run between about 69% and about 73% of our scientists and engineers have advanced degrees, and about a quarter of those have PhDs. So we have a very highly educated workforce. The lower right-hand corner shows you our level of civil service staffing. As you can see, we're stable at about 1,650 civil servants that work at the lab. If I extended this chart back to 1997, it would have been about 2,600 civil servants. So when you look at over the time frame of 1997 to today, we're down about 40% in our civil service staffing. And while that could be viewed as a negative, and I view it that way, what we also can look at it as is that we've been able to focus our activities on things which are potentially more relevant to both aeronautics and space travel. So here's our economic impact in the state of Ohio. Like I said, we receive about $650 million a year of federal dollars, but that results in about $1.2 billion of economic activity here in Northeast Ohio and $1.4 billion statewide. And as you can see, we also contribute about $10 million a year in state taxes. Educational grants, we work with pretty much all the major universities here in the state of Ohio that do any kind of research or STEM outreach activities. The largest of those of the universities that we work with being University of Toledo, which is not unusual because they have a very strong materials program. Now here's the Glenn core competencies. We've always considered or advertised ourselves as having three strong competencies. The first of that being propulsion, the second being communications, and the third being power. So as you can see, air-breathing propulsion, we are probably one of two labs domestically that works with all the civil aircraft engine manufacturers being GE, Pratt & Whitney, and Rolls-Royce, which in this country is known as Liberty Works, which is located in Indianapolis. And we do a variety of things with them. We work on new engine concepts and designs, and then we also work on with these partners to test those new engine concepts and designs in our wind tunnels. So that's air-breathing propulsion. In-space propulsion really relates to two things. And we're not talking about the propulsion that gets you off of the Earth. We're talking about the propulsion systems that are used to get you from either low Earth orbit or near low Earth orbit to another planet. And that can be either with green fuels, and the green fuel of choice today is what we call liquid oxygen and liquid methane. And we have a competency in combustion, and we basically are trying to establish the specifications that would be used for those kind of engines for deep space travel. And then the other type of propulsion we do is electric propulsion, which is a much higher efficiency propulsion system that actually allows you not only to go from the Earth to other planets, but unlike chemical systems, we can actually do tours of the solar system with electric propulsion, because these systems are constant thrusting, low thrust systems that allow us to basically change our orbit, which is not typically done with chemical propulsion systems. So that's in-space propulsion. Physical sciences and biomedical technologies in space relates to the work we do, basic research on the International Space Station. Communications technology and development, we do both aeronautic or aviation communication systems, which are typically air-to-ground communication systems, and we do deep space communication systems. One item of note, we just this week shipped a payload that's going to be launched in the International Space Station that's going to demonstrate a new technology called software-defined radio. And if you're not familiar with that technology is basically taking the power of the computer and using a computer to generate the waveforms so that we can decouple communications from unique design boxes. So today, like on a space shuttle, if you were going to be communicating with the ground, you would probably communicate over one of 4 different bands on the space shuttle. So each one of those bands has a unique radio. With software-defined radio, we can basically replace 4 radios with a single radio and basically communicate on any one of those 4 bands without requiring a uniquely designed box. So that's our communications area. Power and energy storage, a very interesting area that we have at NASA Glenn. We have a competency in flywheels, batteries. We do radioisotope power systems for space application, photovoltaics, and fuel cells. And again, a very broad range of power technologies, but we also do power management and distribution, which we've been working with industry on to find better ways of utilizing power on the grid and hopefully better utilization of the power generating capabilities we have. And then finally, we have a materials and structures capability, coatings, ceramic matrix composites, nanotube, nanomaterials, coatings, I think I mentioned that, and shape memory alloys. So we've worked with a number of companies here in the local area to transition those technologies into more commercial application. Okay, so GRC Awards. The Emmys of technology are known as the R&D 100 Awards. NASA Glenn Research Center, we've won over 100 in over the time frame that R&D 100 awards have been awarded. We win 3 to 4 a year, which is, given the size of our staff, a very great recognition of the technology work that's being done. What I would share with you is if you added up all the R&D 100s awards that are won by other NASA centers combined, they don't add up to the 100 awards we've won here at NASA Glenn. I'll point out the Emmy Award for Communications. If you're not aware of it, back in the 80s, NASA Glenn developed, designed, and launched a spacecraft called ACTS, which is the Advanced Communication Technology Satellite, that led to what is now DirecTV because of the Ka-band communications technology that we demonstrated on that mission. And for that technology, we were awarded an Emmy because of the impact it had on the entertainment industry. We've won a number of Collier Awards, and obviously we had 244 Space Act Awards that were awarded in 2010, which really is a reflection of how much work we do with outside entities. Okay, so we have a part of our goal 5 is not only to reach out to the community and make sure they're aware we're here, but we're really have a huge effort at Glenn Research Center to reach out to the community and see how we can effectively transition technologies that we're developing for either space or aviation use for other commercial applications. Most of the technologies we work on have other terrestrial applications, and I'll give you an example. We're working on technology, a flywheel technology that for space power storage that we believe has a good potential to help solve some power problems here on the ground, both power leveling on the grid, emergency or uninterruptible power sources. So things like that and other technologies that we are working on are part of what we're trying to do to get out with the community and find ways to put our researchers with commercial companies that are in a profit and loss environment and find ways to transition these technologies and see if we can create economic growth by creating new business opportunities for commercial companies. So